On today's episode of Fit Technology News, we're hosting Dr. Neutron, a leading scientist at the IBM Research Headquarters. Doctor has agreed to talk to us about the emerging technology of quantum computing. Dr. Neutron, welcome to our show. It's a great pleasure having you here.
Hello, Dr. DNA. It is very nice to be your guest. I am so glad that you are interested in such an exciting field of science, such as quantum computing.
It is a true honor to have you here. For the beginning, I wanted to ask you, why do we need quantum computers in the first place?
Well, as you know, computers are basically large-scale calculators that operates with zeros and ones. With the correct combination of those zeros and ones, we can do all kinds of calculations. We can make models of very small molecules or atoms in the universe. But these calculations are very complex and require lots of memory.
If I understand you correctly, you're talking about some very complex calculations over there. Even some of today's most advanced supercomputers will run out of memory, and the time required for the calculation will be extremely large.
Exactly. We are talking about thousands of years required for the execution. That is where quantum computers come in hand. Using some of the quantum properties, we can perform these calculations in just a couple of seconds.
Wow, that is very amazing and interesting. But what is it that makes quantum computers so much different than the regular computers? What technology did you invent? And most importantly, when can we expect quantum computers sitting on our desk?
You know how I've said that normal computers operate with zeros and ones? Those zeros and ones are called bits, and basically they represent whether current is flowing or not through the transistor. In quantum computing, we have similar, but very different unit of measurement called the qubit or quantum bit.
I know about the analogy where you can compare bits to coins. If I remember correctly, if you compare the bit to a coin, in a case where the coin is pointing heads, we can analogize that to a bit in the state of 1 and the tails to the state of 0. But I don't understand, how can we use the same analogy for the qubits you mentioned earlier?
The qubit in this analogy would be represented by a spinning coin. If you have a coin that is spinning, you can't exactly tell whether it is showing heads or tails. All you can say is that it is some combination of heads and tails. The same applies for the qubit. So basically it is a combination of zeros and ones. That is one quantum property that we use for designing these kinds of computers.
Are there any other quantum properties that we can use for designing these kinds of computers?
The other quantum property is called entanglement. This is a property in which the qubits are connected or entangled, so that when we affect the state of one qubit, we can affect the state of others. This is very useful for saving energy, for example, because in order to measure the state of a qubit, we need to cool them down to a very low temperature, and that requires lots of energy.
That is very interesting, Doctor. I'm sure that our viewers are very impressed by what you have achieved in your laboratory, but this is all theory. Can we see the power of quantum computing in action?
Of course we can. I have played a little game with my students. They had to choose whether my computer would turn a coin to heads or tails. First, they have made a choice, then my regular computer made the same choice without knowing what my students have chosen. In the next round, both the computer and the students had the option of switching their choice. We had 2 more rounds of that. After that, the computer would reveal its selection, and if the students guessed correctly, they would get a point, and if they missed, the computer would get a point.
Wow, I can only imagine what the results were.
Unsurprisingly, after 100 played rounds, the results were close to 50-50. Next, we played the same game, but this time on the quantum computer. This time, after the 100 played rounds, the computer won 97 of them. He lost the 3 only because of some computational errors. Here we can see the true power of a quantum computer, and that is uncertainty. We can use it to model molecules, for example, or for internet security, making the computers that implement quantum technology for encryption practically unbreakable.
Thank you, Dr. Neutron, for your extensive lecture today. I'm sure that our viewers have truly enjoyed what you had to present to us. Dear viewers, That will be all for today. This was Dr. Neutron from IBM Research Headquarters talking about the power of quantum computing. In the next episode of Fit Technology News, we will have Dr. Paul Immerse talking about the 5G technology. Until the next time, stay safe. Bye!